Well, good morning, ladies and gentlemen. We should be on lesson 3.5. As I wanted you to do, I wanted you to work these problems out on the engage and explore on your own, and then look back at it, and then we'll come back to it. And then that's what the purpose of this video is for you to see these problems worked out and explained. So I'm just going to reread the question stem and let you know. So Tommy, aka me, visited the Museum of History and Technology with his class. They saw Foucault's pendulum in Pendulum Hall, and it was fascinating to Tommy. He knew that from science class that the time it takes a pendulum to complete a full cycle or swing depends upon the length of the pendulum. The formula that's given is T equals 2 pi times the square root of L over 32. And the T represents the time in seconds, and L represents the length of the pendulum in feet. So he timed the swing of the pendulum, or I timed the swing of the pendulum with my watch, and found that it took 8 seconds for the pendulum to complete a complete cycle. All right? Help me figure out the length of the pendulum in feet. All right? So all we're going to do is fill in the parts. So first of all, our time, or T, is going to be 8, and it's going to equal 2 pi times the square root of L over 32. Now, we could have solved this for L already, but since I already went ahead and committed to it, we'll just go ahead and solve it. All right, so first thing I want to do is I want to divide both sides by 2 pi. Okay? When I do that, I should wind up with, and I'm rounding because it was a pretty large number, 1.273, and that would be equal to the square root of L over 32. Now, because we have this radical, to do the inverse of the radical, we're going to square both sides. And then that's going to give me, again, something I rounded, 1.621 equals L over 32. All right. Then lastly, to get L completely by itself, I'm going to multiply both sides by 32. Because we're dividing by 32, I'm going to multiply by 32. And when I do that, I should get approximately 51.88 feet. And that should equal L. All right? So that would be the solution to the first problem under engage. So if I was in class, we would have did this too, and you would have given me a few minutes to work on this. So the last question under engage says, what could help affect the full cycle of the pendulum? Well, first of all, one of the things you got to realize is essentially what's mainly going to affect the full cycle, or the T, would be L, and that would be our length. So depending on the length, if the length is shorter, you have to think about that. You can play around with that number and see what it would be. And if it's longer, again, how long would that be? So we can speculate, and in the next problem, you'll see kind of what happens when we change the length in terms of, and then how that may be affecting time. All right? So hopefully you've done both of these, so I'm going to go ahead and kill 2 birds with 1 stone. All right? So let's move on to the next page, or the next problem. All right, so again, I thought that the pendulum that took a full 20 seconds to complete a full cycle would be very dramatic for a museum. How long must the pendulum be? All right, so first of all, we need to solve and figure that out. So again, we use the same formula. This time we're going to put 20 as our T because that's our time. And that's going to equal 2 pi times the square root of L over 32. And just like before, we're going to divide both sides by 2 pi because we're trying to get L by itself. And we should get, again, approximately, because I'm rounding because it was a big number, or a long decimal, I should say, 3.183 equal to the square root of L over 32. And just like before, we're going to square both sides because I want to get rid of my radical. And again, this is the square root. We're going to raise it to the second power and get approximately 3.1314, equals L over 32. And then lastly, we're going to multiply both sides by 32. Since we're dividing by 32, we want L by itself or isolated. And we should get 324.20 feet. And that's going to equal L. All right, so that's how long the pendulum will have to be. If we want 20 seconds with the same formula, then we want to we want 324.20 feet. So as you can see, comparing with the first one, when we had 8 seconds, it was 51.88 feet. So again, as you can see, this is what would affect the full cycle of the pendulum. Okay, so the full cycle of the pendulum would be affected by the length of the string. So if it's longer, like in this case, the time is longer, that means the length has to be longer. So in converse, if the time is shorter, that would have to mean that the length of the pendulum would be shorter. All right, so the last question asks us, if the ceilings in the museum are about 20 feet high, would this pendulum be possible? So I don't know if you know, but think about it. Isn't 324.20 longer or more than 20 feet? So again, we're not going to be able to use this one. So unfortunately, I will not be able to see a 20-second pendulum. Well, it's a pendulum that takes 20 seconds to complete a full cycle, basically meaning go all the way around 360 degrees. Well, thank you for paying attention. And like I said, now I want you to work on the review problems under the Google form. Remember I told you it's basically going to give, it came out to be 16 questions. So try your best. I'm grading out for completion. The correct answers are given, so you will be able to look at that. And if there's anything you don't understand, make sure you make a note of those questions, and then we'll go over that when I return. Thanks, and have a good day.